A very good morning to you, dear children. We are going to begin a new chapter, force and pressure. Understand? Let us get clarified about the terms force and pressure. What is force? What is pressure? அப்படின்றத நம்ம தெளிவாக புரிஞ்சுக்கணும். So there is a definition, okay, which explains force is the push or pull exerted on a body. Understand? So force is a push or pull அப்படின்னு சொல்றாங்க. It's a push or pull. So there are two types of forcesன்ற மாதிரி நம்மளுக்கு ஒரு ஐடியா கிடைக்குது. It is a pulling type of force, இன்னொன்று pushing type of force. So you know what is the meaning of pushing? Understand? If you have to open a door, you push the door to open it. Understand? If you have to just pull a car, how to pull a car? ஒரு கயிறை கட்டி இழுத்துட்டு போகிறோம். That is a pulling type of force. இல்லையா? So let's watch a video, and after watching that video, I will try to explain the points which are there. Understand? So that video will explain you about what is force and what is pressure. Kindly follow the video till the end.
Force. We hear the usage of this term many times in our day-to-day life. We might not know that we're using it. Opening a door, riding a bicycle, lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who's standing on the other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate. When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk here at point A. A person wants to move this desk from point A to this point B. Again, how will he do that? Here, he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some object from the table, we say that you applied a force on that object. Here, the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here, pedaling is the force that we apply on a bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening a drawer, plucking the string of a guitar, moving a piece on a chessboard are some of the other actions performed on objects. So performing these actions on objects is nothing but applying force on them. But these are just a handful of simply too many actions that we can perform on the objects. And it's not possible to write each one of those. But we can categorize all these actions into two basic ones. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we open this drawer, we are simply pulling the knob of the drawer to open it. Similarly, when we are drawing or lifting a bucket of water from the well, we are pulling the bucket towards us. What are the actions that can be described under pushing? Actions such as passing the ball, hitting the hammer on the nail, etc. can be thought of as pushing an object. Are there any actions that can be described under both? Yes, there are. Suppose there's a book on the table, you can either pull it towards you like this or push it away from you like this. So moving an object can be described under both. Similarly, opening or shutting a door can be thought of as both. So we can safely say at this point that the forces are nothing but the push or pull applied on objects. Forces are due to interaction between the bodies or objects. What does it mean?
So, after watching this video, we should have understood what force is. இல்லையா நம்ம அந்த வீடியோவில் என்ன பார்த்தோம் நம்மளோட டே டு டே ஆக்டிவிட்டீஸை பார்த்தாங்க many activities were shown like opening a drawer, understand, stopping a football, kicking a football, and pedaling a cycle, swimming, like this different types of activities were shown. In all these activities we need an external agent that causes a change in equilibrium of the object. ஸோ நான் இப்போ வந்து புதுசாக ஒரு டெஃபினேஷன் சொல்கிறேன் ஃபார் ஃபோர்ஸுக்கு. Force is an external agent that causes a disturbance in equilibrium of a body. சொல்லலாமே ஏன் what is the meaning of equilibrium? I leave a pencil on the table, understand, the pencil remains there forever. அங்கேயே இருக்கும் எப்போ நான் அதை நகர்த்துற வரைக்கும் அங்கே தான் இருக்கும். The pencil will not be moving unless I apply an external force on the pencil and make it move. So I need some external agent to act on the pencil to disturb its equilibrium. Either I have to lift the pencil and put it in a new place. Otherwise ஒரு பலத்த காற்று வீசுது. இப்போ அந்த காற்று வீசும் போது என்ன ஆகும் பென்சிலை நவுத்திட்டு போயிடும். அப்போ force in the form of wind இது. Okay, the moving energy, the kinetic energy possessed by the wind causes the pencil to move. அதனால what is force அப்படின்னா it is a push or pull exerted on an object அப்படின்ட்டு the video was concluded. To make things much clear, we will watch the next part of the video which explains much better about force.
What is force? Let me tell you what you will probably read in your textbooks. Force is a push or pull upon an object, right? Though this cannot be really classified as incorrect, it hardly explains anything about the concept of force. This is what you will assume after reading this definition. You will imagine a stationary object on the ground and someone pushing it or pulling it. Yes, when force is applied, the stationary object will move. But just this does not explain the concept of force entirely. Before we move on to the definition of force, let's clear a few misconceptions about it. Let me ask you a question. This ball is lying at rest on the ground. It's stationary, not moving at all. Is there any force acting on it? Listen to my question carefully. Are there any forces acting on the ball when it is stationary? If your answer was a no, or if you didn't have an answer, it means you don't know the concept of force yet. The answer is yes. There are forces acting on this ball. There is a gravitational force which is trying to pull the ball towards the center of the earth. And the ground is applying an equal force exactly in the opposite direction. This force is called the normal force. Because these two forces are balanced, they do not change the position of an object. The net force acting on the ball is zero. So what does this tell you? Just humans pushing or pulling is not the only kind of force. And just because there are forces acting on an object will not mean the object will move. For the object to move, there has to be some net force. So now let's say a person softly kicks the ball. What happens then? Yes, the position of the ball changes. Why did the position change? It's because there was another magnitude of force acting on it, and this time the forces were not balanced. The ball moved and there was displacement. But hold on. Why did the ball stop moving after covering 15 meters? The ball started moving at a pace and then slowly came to a halt. If there's no force from the other side to stop it, how did it stop? Was there a force which stopped it? Yes, it was friction that stopped the ball. While the force you applied was towards the right, the force of friction was towards the left. Let's make it even more interesting. Assume your screen to be a frame of reference in this example. Also assume that this straight horizontal line is a frictionless flow and there's no air resistance. The ball appears from the left of your screen and moving towards the right at a uniform velocity of 2 meters per second. The only two forces acting on the ball are the gravitational and the normal forces which net each other out. In this setting, will the ball ever stop moving? No, it won't. It will continue to move along the same path at the same speed unless there is another external force which acts on it. Here, as the forces are balanced, the ball will continue to move at 2 meters per second. Most people assume that if the object is moving, then there is some net force acting on it, but that's not true. An object will continue to move at uniform velocity even if the net force on it is zero. So there are two things we've learned here. First, if the object is stationary and the net force acting on it is zero, then it will continue to remain at rest. Second, if the object is moving at uniform velocity and the net force acting on it is zero, then it will continue to move at that same uniform velocity. Now, when this ball is moving at 2 meters per second and there is an external force applied from the left, what will happen? Yes, the ball will accelerate. Its velocity will change. Let's say the velocity changes to 3 meters per second after this external force is applied. After that, the ball will continue to move at 3 meters per second unless acted upon by another external force. So nobody's really seen or touched force. It can only be understood by knowing what happens to an object when force is applied to it. If the body is stationary, do not assume that there is no force acting on it. And if the body is in uniform motion, do not assume that there is some net force acting on it. So what is force? A force is a push or a pull upon an object resulting from its interaction with another object. So when you kick the ball also exerts some force onto your leg. But as the force of your kick is stronger, the ball moves to the right. There are many more concepts we need to understand about force, which we will cover in the next video.
So, that part of the video explains how force acts on a body. William, when you leave a ball on the table, the question was wonderful. Okay, when the ball is left stationary, what is the meaning of stationary? At equilibrium, without disturbing, body at rest. So, ஒரு இடத்துல அந்த ஆப்ஜெக்ட் அந்த பாலை வச்சுட்டு அந்த பால் மேலே ஏதாவது ஃபோர்ஸ் ஆக்ட் பண்ணுதா அப்படின்னு கேட்டோம்னா, if our answer is no, then we are not understood about force ன்னு அர்த்தம். The force அப்படின்னு சொன்னாலே, இப்போ ஒரு ஆப்ஜெக்ட் பாலை வந்து டேபிள் மேலே வச்சிடுறேன் அப்படின்னு சொன்னோம்னா, the force of gravity acts on the ball. Understand? And that is, we call it the gravitational force which acts in the downward direction. There is another force that acts in the upward direction, keeping the ball over the table. அந்த பாலோட சர்ஃபேஸ் மேலேயே நிற்க வேண்டிய ஒரு ஃபோர்ஸ், அதாவது பால் வந்து டேபிளோட சர்ஃபேஸ் மேலேயே இருக்கணும் அப்படின்னு சொன்னோம்னா, அந்த பால் மேலே இன்னொரு ஃபோர்ஸ் ஆக்ட் பண்ணுது. இது ஆப்போசிட் டு த டைரக்ஷன் ஆஃப் கிராவிடேஷனல் ஃபோர்ஸ். there is a force acting which we call it the normal force. இப்போ இந்த கிராவிடேஷனல் ஃபோர்ஸ் இருக்குது அப்படின்னு சொன்னாலே நார்மல் ஃபோர்ஸும் இருக்கும். இப்போ கிராவிடேஷனல் ஃபோர்ஸ் எப்படி? இட் இஸ் அ புல்லிங் ஃபோர்ஸ் ஆக்டிங் டுவர்ட்ஸ் த சென்டர் ஆஃப் த எர்த். இப்போ ஒரு புல்லிங் ஃபோர்ஸ் அப்படின்னு சொன்னோம்னா என்ன பண்ணோம்? இழுத்துட்டே போயிடும். இப்போ கிராவிடேஷனல் ஃபோர்ஸ் இருக்கு, நார்மல் ஃபோர்ஸ் இல்லை அப்படின்னு சொன்னா என்ன பண்ணுவோம்? நம்ம பூமியை பற்றி கீழே போயிடும். ஆனால் நம்ம போகாம மேலேயே நிற்கிறதுக்கு என்ன பண்ணுது? The floor is offering a force with the upward direction, keeping me on the surface of the floor. அப்போ when I stand on the floor, for example, if I am at rest, what happens? The gravitational force is being balanced by the normal force. When both are equal, when the net force is zero, I am stationary, I am stable. Okay. And in the video, you would have seen the ball moving. அப்போ என்ன பண்ணுறாங்க? நார்மல் ஃபோர்ஸ் இருக்குது, கிராவிடேஷனல் ஃபோர்ஸும் இருக்குது. இந்தாண்ட பக்கம் என்ன ஆகுது? புஷிங் ஃபோர்ஸ் கொடுக்குறோம், எட்டி வதைக்கிற பாலை எட்டி வச்சோடனே என்ன பண்ணோம்? பால் உருண்டு பூமி மேலே அப்படியே நகர்ந்து போயிட்டே இருக்கும். நகர்ந்து போகும்பொழுது புஷிங் ஃபோர்ஸ்னால பால் நகர ஆரம்பிச்சிருது. ஆனால் பூமிக்கு மேலே இருக்கிற சர்ஃபேஸ் மேலே இருக்கிற ஃப்ரிக்ஷனல் ஃபோர்ஸ் ஆல்வேஸ் ஆக்ட்ஸ் in the opposite direction of applied force சொல்லுவோம். எந்த டைரக்ஷன்ல நம்ம ஃபோர்ஸ் அப்ளை பண்றோமோ அதோட ஆப்போசிட் டைரக்ஷன்ல ஃப்ரிக்ஷனல் ஃபோர்ஸ் ஆக்ட் ஆகும். அப்படி ஆக்ட் ஆகும்போது என்ன ஆகும்? the ball will come to rest. எப்ப pushing force கம்மியாகிட்டே போவோம். பால் உருண்டு போகும்போது என்ன ஆகுது, அப்ளை பண்ற டைம்ல புஷிங் ஃபோர்ஸ் அதிகமாகுது, ஃப்ரிக்ஷனல் ஃபோர்ஸ் கம்மியா இருக்கிறதுனால பால் உருள ஆரம்பிச்சிருது, வேகமா உருள ஆரம்பிக்குது. போக போக என்ன ஆகும் அப்படின்னா புஷிங் ஃபோர்ஸ் குறைஞ்சிக்கிட்டே போவோம், ஃப்ரிக்ஷனல் ஃபோர்ஸ் அதிகமாகிட்டு போவோம். அப்ப என்ன ஆயிடும், ஒரு கட்டத்துல the ball will come to rest. இப்ப when the ball comes to rest, both the pushing force and the frictional force are zero now. What are the two types of force that will exist on the ball now? The gravitational force and the normal force will exist. That will be giving a net force which is equal to zero, that makes the ball stationary. So that was the explanation wonderfully given there in that video. Now we will go to another video. We will watch another video for a better explanation about force.
In the first part, we saw that force is not just a human pushing or pulling an object. A force is a push or pull upon an object resulting from its interaction with another object. There are two things we will cover in this video: types of forces and the effects of forces. For simplicity, we can classify forces into two types: contact forces and non-contact forces. Contact forces are just what they sound like: forces that result from the interaction of two objects in contact with each other. Are there any contact forces you know of? Of course you know a few. What happens when you softly kick the ball which is lying on the ground? You applied a force on the ball and there was contact. Applied force is one of the contact forces. Next, there is a force of friction which brings the ball to a halt. As the ball is in contact with the ground, the frictional force is also a contact force. Don't you think there was some air resistance? Yes, air resistance too is a contact force. The normal force, which is applying force in the upward direction, is a contact force as well. These were some of the contact forces we know of, but these are not the only ones. Can you think of any non-contact force? What happens when the ball is in the air? It will fall down, right? What pulls the ball down? Yes, it's the gravitational pull which is trying to pull the ball towards the center of the earth. This pull happens even if the object is not in physical contact with the earth. The gravitational force is an example of a non-contact force. Other examples of non-contact forces are electrical and magnetic forces. Now, I want you to think about the next question I'm going to ask you. What all can a force do? What can be its effects? Let me give an example. A force can set a stationary object in motion. That's one of the things force can do. Can you think of the other things it can do? Assume an object is moving at a uniform velocity of 2 meters per second. If it is pushed harder, its velocity will increase. So force can also change the velocity of an object. A force can also stop a moving object. Anything else you can think of? Yes, force can also change the direction of a moving object. If a ball is moving towards the north, a kick from the right can change its direction to northwest. Is there anything else you can think of force can do? Come on, I want you to think really hard. Don't think only in terms of motion.
Force and motion. Students, force changes the state of rest or motion of a body. Here is an activity to prove it. Keep a tennis ball on a table and push the ball slightly with your hand. What happens to the ball? The ball at once sets into motion, isn't it? Now, keep your hand on the opposite side of the moving ball. What happens then? The moving ball comes into a state of rest. This proves that the force changes the state of rest and even the motion of a body. Students, force can change the shape of an object. The change produced by a force on a body cannot be observed clearly. Look at this activity. Do you have an eraser? Take an eraser. Then insert 2 nails, each of 1 inch, at the near ends of the eraser. What change do you observe in the eraser? You will observe both the ends of the eraser near the nails slightly increase. Similarly, when a spring is stretched holding it in between 2 hands, the shape of the spring will be changed. Students, force can change the direction of an object as well. To prove this, look at the activity. Do you have a toy car or a bus or even a motorcycle? Take a toy car or a bus or a motorbike and tie a thread in the middle of one side of a spring around the car. Allow the toy car to move on the floor. It moves straight when it is in motion. Now pull the spring towards you as in the figure. Does the direction of motion of the car change? It does. Similarly, when a football player strikes the moving ball in another direction, the ball changes its direction.
Well, dear students, இப்போ effects of force பற்றி நம்ம அதில் பார்த்தோம் இல்லைங்களா? So, from all these videos that we have watched so far, we should have understood what is force, what are the types of forces, and what are the types of forces that act on a body at rest, disturbing its equilibrium. Like this, many concepts we have known. I think, dear children, you should be very clear about the concept of force and the effects of force on a body. So in the next video, we will just learn about what is pressure. Understand? Thanks for watching.